There once was a man called Enos, who had an extraordinarily large penis. He stuck in his thumb and pulled out some cum and shot his way off towards Venus. Greetings, the Astro 30 here yet again, and today I'm making a PCB, which is just sitting over there in the left of screen, for that linear volume control circuit. I've already exposed and developed the board. I'm just waiting for the kettle there to boil so I can etch the thing. Alright, pour water into the ammonium sulfate solution. Probably be about right there. Drop the board in, and I'll start agitating it, and see how long this takes to etch. Probably about 20 minutes. Okay, and about 40 minutes later it's etched, albeit I had some difficulty because some of this did not want to eat the copper away. It looked like there was like fingerprints all through the resist in certain areas, and it just took a hell of a long time to etch. But it's etched for the most part now. Well, actually it is etched. I'm sure that it's going to work out just fine. So all I need to do now is drill the holes out. Size up the holes to fit the parts correctly for larger parts like the pot and connectors and stuff. Cut it down to size, remove the resist, put some circuit board lacquer on it, let it dry, and then we're ready to assemble. Yippee-ki-yay! Okay, and there's the circuit board all cut and drilled, albeit I had a little bit of a problem on this side. It's a little wonky. Started cutting through the ground plane trace there, but doesn't matter. No. Will it still work? Yes. Now, the astute viewer might notice there are no mounting holes to mount it to a chassis. Well, the reason for that is simple, is because the potentiometer actually mounts it to the front panel. So it'll mount to the front panel using the potentiometer. I'm pretty sure that that edge is pretty close to the what's that thing called? The lip of this control here, so it will be very close. If I have to use a spacer washer there, I'll use a spacer washer there. Now, I've also changed the potentiometer from a 50k to a 100k linear to give me just a little bit more of a smoother control there. And so now what I'm going to do is I've got all the parts laid out on the bench here ready to solder in. I'm going to solder the op amps directly into the PCB because I don't have any IC sockets, and I thought I did. So the breadboard version, I just took the op amps out of that because I know all those op amps are functioning, so I don't have to worry about after soldering in nothing working. So let's get set up. And there's the circuit board assembled there. I've put a little blue mark just here near the connector where the negative 15 volt is. Zero's in the middle, positive's at the top there. Just so I don't accidentally connect it around the wrong way, because connect it around the wrong way, say bye-bye to these op amps. So that's why it's probably a good idea to use IC sockets there. But as I said previously, I don't have any. Other problem is I'm going to have to make up these sodding plugs with audio cable on them to get an input and output signal, well, input and output signal I should say, into a power amp with audio. But for testing purposes I should be able to just hook an oscilloscope probe to each of these pins where they go. I'll show you the overlay in a minute. Just to actually put it into an oscilloscope from a DDS just to test that the circuit is operating. With wiring these cables, I'll do that tomorrow. It's getting late in the day and I can't be bothered anymore. You know, you get to that point. I've already done like 2 video projects today, so it's been a big busy day. So this is the overlay diagram that I've done from my CAD software, and then I put it through a paint program just to make the tracks duller so that they're not the same color, because I've only got black and white. It makes it very hard to read the component values. Anyhow, this is the input side, this is the output side, so that correlates to here and here. Now, left is on this side of that connector, the input connector, and left on the output is on the opposite side. That's just because of the way it ended up being routed, because there's a link wire here and a link wire there, and I didn't really want to end up adding any more link wires. 2 is probably a little bit much for this. It probably could have been routed a little bit differently to eliminate at least one of these links, but when you're working with single-sided circuit boards, yeah, it is what it is. This is the crudely drawn schematic. I've marked them as C1A, C1B. On the overlay it's C101, C201 respectively. So there's our 2 op amps. I'm leaving this as 1K in this board because this will be used with that Class D module that I've got lying around when I've built the other channel, as basically its preamp volume control section. Of course it's going to go out into a separate tone board with bass, treble, mid-range controls on them. But because the input sensitivity of that power amplifier is pretty high, it says in the instructions 2.2 volt RMS for full output. So I shouldn't have a problem with a tracking issue at the bottom of the volume pot so much, because there won't be that much volume coming out of it at that end. Probably more around about, you know, 730 on the rotation there before we get any audible sound out of it. So that's the schematic. I'll draw this up properly. It hasn't changed much from Rod Elliott's design on his website. I've used the 100k potentiometer instead of the 50k originally, as I already previously stated. So now it's time to hook this up to a power supply, oscilloscope and DDS, and we'll just make sure that we're getting an output and everything's all hunky-dory. Okay, got everything set up. DDS is set to 1 volt peak to peak, 1 kilohertz, the customary setting, and this power supply is proving to be quite a godsend here, even though there's been some speculation online about those modules that I used are crap because they're using underrated op amps and shit in it. But yeah, anyway, oscilloscope is set up there, so now I need to turn the load on. Got no current draw, no output. There won't be when the volume control's all the way down, so I'll just rotate the pot. And we do have an output, albeit I can't really see it very well. So let's change a few things here. Kick the tripod yet again. That's a bit better there. 1 volt peak to peak. I mean 1.1 volt per division. and we're getting close to 10 volt out. So that channel is working, and working nicely by the looks of things. It's very quick to respond above the halfway point as previously mentioned, but below that point it's very slow. So I just changed the voltage per division range down, so we're now at 0.2, 200 millivolt per division. You can see it backs off to 0, and it's fairly logarithmic at the bottom end, so yeah, that's working nicely. Okay, now to test the right hand channel. So with that powered up, I should be able to just swap these probes around, so I might try swapping this one around first, preferably without trying to short it to the earth. Okay, now we're on the other channel. Rotate the pot, and we do have audio. I can't really see at the moment. I think that's about the same responsiveness as the other channel. Looks pretty good. Just increase that voltage per division. And yep, we've got 10 volt peak to peak coming out. Very good. So it's operating as a amplifier with a gain of 10, which it should be. So those op amps are working fine. Didn't do anything destructive to them when soldering them in. So it should output audio into a power amp just fine. So I might do a sweep test just for the hell of it. I mean, you know, why not? Okay. See how flat it is. I'll put it up full so we can see. Okay, let's go. Reasonably flat, staying at 10 volt. Yeah, hovering around 10 volt. Dropped off to about 9.5 now. That's at the very high range. Starts off at 10. So, yeah, it's relatively flat. So we'll take that off. So very, very good. That little circuit board is working just perfectly. As for layout, whether or not it's going to pick up any noise, I didn't see any on the oscilloscope. Remains to be seen when hooked up to an amplifier, but as I said, I'll do that tomorrow because I can't really be bothered now. But it is working, so I can hook it up to an amplifier and test it out. So, and that's what happens with non-inverting amplifiers when you actually turn the voltage off. See, we are getting some bleed through there. That's up with the volume control up full. I'm getting close to a volt there, peak to peak, and with it rotated all the way minimum, I'm getting about 56 millivolt, 560 millivolt. So yeah, there is a bit of bleed there. Turn the DDS off and it goes away. Well, it's the next day, everything's all set up, it's all Frankenstein penis. I've got the audio input lead here, I've got the audio output lead here connected to the two Class A modules over there connected to the speakers, and I'm hoping I've got everything connected right. So all I'm going to do is just I'll make sure nothing is shorting, which I don't think it is. It doesn't appear to be. Right, I want to be very careful here not to disturb any of this wiring when playing with the knob, or else it's going to short circuit something. So I'll turn it on. Didn't hear anything unusual. I don't seem to have anything coming out the right. Well, that's interesting. The right hand module doesn't appear to be working. Okay, just give me a minute. Okay. I do have both inputs working. I'm picking up RF interference on that knob, but now I need to hook it up across the CD player and excuse me, and see what sort of output we get. Well, it should work, so let's find out. Got some nice sunshine going on outside. Now I've got the CD player hooked up, so I'll just select a random track. I don't really particularly care what it is. Track 15 will do. Let's press play. Helps to turn it on. Yeah, that seems to work alright. I'll just let the next track play. Well, not that one. It's fucking annoying. Okay, well, we've probably heard that track enough this video. It's working, yes. The volume control is currently sitting quite high up to get decent output. Now we can imagine if that potentiometer had a knob on it, the flat side, with a grub screw, the arrow would be pointing diametrically opposite to it, so that is about a third of a turn, something like that, which would be probably pointing to the 11 o'clock position, somewhere there, which is quite considerably high. But at the same time I'm going into two low-powered amplifier modules running on 15 volt. Now if those power amp modules off to the right of screen there are running on the 424, we would technically have double the output, because we've got double the voltage there. Because it's limited down to 15 volt or thereabouts, it's not exactly double, it'll be probably about 1 1/4, something like that. You'd get more power out of the power amplifiers obviously, and therefore the volume control potentiometer would be turned down a bit further to get the same level. But it's all relative to the power supply voltage. And as I said, because the power amps are running on 15 volt instead of 24, the power output and the amount of sound pressure level delivered to the speakers is going to be a lot less. But it is working. I am picking up, well I was when it wasn't grounded, but I was picking up noise on the potentiometer when I was rotating it from my fingers. So it does need to be well grounded. But yeah, it works. I'm happy. I can move on to the next thing. So anyway, I'm the Astro 30. If you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyhow, this is the Astro 30 saying see ya. Happy Linear Volume Day.